Alright, go for it, whenever.
Dare you to say my animals, there's fire, oh no!
OMG's fire, woo! Fire, oh my god, fire, woo! Oh my god! Woo, save us, woo, man, woo, fire! Oh my god!
This is the system I've come up with to save my dear animal friends from the fire. There's stairs over there, but they're broken.
The most that any rope or sheet can sustain is 1.3 kilonewtons. Daryl was planning to save my stuffed animals by climbing up the rope and bringing my sweet animals down with him. If Daryl says he weighs 65 kilograms and we know that the rope can only sustain 1.3 kilonewtons, we have to figure out how much mass my animals can weigh for them to get down safely and come back home without being burned. Before we can solve for anything, we have to draw the system. We do so by first drawing a y and x axes. And the system, we measured the angle. This was 60 degrees. And we can call this F1. And then this is where Daryl is going to climb down from. So we can call this F3 only because here the rope is attached to the wall. So this is going to be F2. We can call this C and B. This can be A. So here's our system. For F1, we know that we would have F of B sine of 60, and then for F2 would only equal F of C. We're just separating the forces. F3 will be Daryl's weight, his 65 kilogram weight, and from before we knew that the force that the rope can sustain is 1,300 newtons or 1.3 kilonewtons. And so we know it'll be the total weight. This will be the weight of, or the addition of, the animals. And we multiply that by 9.81 to get newtons. And we know that it can't be greater than 1,300 newtons. It can be equal to, but not greater than. So that's just an assumption. Okay, so because we know this is the max, we can assume that it will be equal to 1,300 newtons. So we have our known data, and we have our three formulas for the different forces. Well, we know what the forces are equal to. And we can do some of the forces in the x direction, which would be negative FB cosine of 60 plus F of C. We know that because although I wrote this is in the y direction, but we also have the x direction. So we have C going this way, so that's why it's plus FC, and we have negative FB because it's going in the negative x direction, and this is cosine of 60, so for x we always use cosine. And then we also have the sum of the forces, which would equal 0 because it's at equilibrium. Then we could do the sum of the forces at y, which would also equal 0, and that's going to be equal to FB sine of 60 minus F of 3, which was 65 plus W times 9.81. So, as I was saying, we can assume this is 1,300 newtons because we had said that we were going to set it before to the max force that it can have, because we all know Daryl's fat and we don't know what's going to happen. So we had to figure out the weight, correct? So we can use this, and solve for, we can rewrite this as FB sine of 60 minus 1300 newtons because of our earlier assumption. And then all this has to equal 0 because it's at equilibrium. So FB sine of 60, we can add 1300 on both sides, is equal to 1300 newtons. And so we can divide by sine of 60 to get FB alone. And when we plug that into our calculator, 1300 newtons divided by, make sure the mode is in degrees, and 1300 newtons divided by sine of 60 is going to be equal to 1501.1107 newtons. Because this is a very large force and it's more than 1300 newtons, we can, okay, so because we got the larger force here, we know that this is controlling the system. So we want to make this smaller, so we're setting this one to 1300 because we're assuming that this controls the system. So we can plug 1300 for FB in our original equation. So we'll have, for some of the forces in the y direction, equals FB sine of 60 minus 65 plus W, 9.81. And so we're not assuming this is 1300 anymore, we're assuming this is 1300 because when this was 1300, FB was too big. So we're assuming that FB is 1300. So we can have 1300 times the sine of 60 minus 65 plus W times 9.81. When we get that, when we do that, we get 1300 sine 60 is, so when we do 1300 sine of 60 in the calculator, we get that it equals 1125.83 minus 65 plus W, 9.81. So then we have 1125.83. All this is equal to 0. So we can add this on the other side. And so 65 plus W times 9.81. So that's equal to each other. We divide both sides by 9.81. And we get 114.67 on this side is equal to 65 plus W. And then we can subtract 65 on this side and subtract 65 on this side. Then we get the weight, or the mass, 49.67 kilograms. Okay, so the largest mass that my animals can have is 49.67 kilograms. I don't know if that'll still work because Daryl, sorry to say this, he's somewhat obese. And if my animals don't get through this, I don't know what'll happen. But Daryl's gonna go down, so they better get through this. It's really serious. Oh my God, Daryl's gonna go get him. Look at the fire. Oh my God. Come on, Daryl. Save him. Fail. They're gonna commit suicide. Oh my God. Oh my God. They're jumping because you failed them. Oh my God. I hope you're happy. You failed. That's so sad. They're dead.
Moves.
Look. These poor, my poor animals. You failed. I hate you, Daryl.
He was very young. Sheriff Jackson never remarried, so I sort of stepped in,
Not yet.
killed her off.